Welcome to the last lesson of Chapter 12, 12.6. We are going to work on dividing polynomials. We're going to see a couple different versions of this, starting with dividing a polynomial by a monomial. So if you remember, a monomial is a single term, one term. Those will be polynomials that don't have a plus or minus sign. So we have our first example here, divide 6x cubed plus 8x squared minus 4x. Divided by 2x. So we're going to rewrite that first polynomial, 6x cubed plus 8x squared minus 4x. And when you divide by a polynomial, we're going to divide every single term by that polynomial. This is going to feel familiar. You guys have done similar things to this before, so we just have to remember that to divide the entire polynomial by a monomial, every single term gets that division. And then we're just going to simplify this. So 6 divided by 2 is 3, and x cubed over x, we subtract our exponents and get x squared. Plus 8 divided by 2 is 4, x squared divided by x, you keep your x, subtract your exponents, and get x to the first power. Minus 4 divided by 2 is 2, and those x's will cancel. So here's our resulting polynomial when we do that division. Now let's take a look at dividing a polynomial by a binomial. So binomials have two terms. You can see in our examples we have two terms in this division. You guys have done these before. So what we want to notice is that because we're working with polynomials, you have your plus and minuses, we are going to think factoring on this. So we want to get each polynomial into its factors and then see if we can reduce the factors. So for this first polynomial here, we're looking at factors of -5 that add up to a +4. So remember, your factors are 1 and 5, but we need one of them to be negative to multiply to a -5. And then remember, that larger factor will always have the same sign as your b value, so I know to make the smaller factor negative. So just to double check, -1 times 5 is -5, -1 plus 5 is a +4. So we can go ahead and write this in factored form. X minus 1 times x plus 5, so those are our factors of the polynomial, divided by x minus 1. And then what we notice is that we have an x minus 1 in the numerator and an x minus 1 in the denominator, so those do cancel out or divide out, and our resulting polynomial is this x plus 5. So feel like you've done that before? Yeah. Okay. So this next example, we are going to do the same thing. We have a trinomial divided by a binomial. So we're going to factor the numerator, factor the denominator. Have you guys noticed that our numerator has a 3 in front of the x squared? We'll do a quick double check to see if that's a GCF. It's not, and there is no GCF. So this takes us back to our guess and check factoring. So if we remember, what goes into our first spot of each parenthesis has to multiply to a 3x squared. So 3x times 1x. Remember, 3 is prime, so it only gives us those options. What goes in the second spot has to multiply to this -8. Well, we have some options. It could be 1 times 8 or 2 times 4. And we do kind of think ahead a little bit to try to figure out what might work well. We guess something, and then when we check it, see if it works out to get that -10x in the middle. So I'm going to try because I already know what it is. A +2 and I'm -4. So let's just double check. So if we check our outside terms, 3x times -4 is -12x. 2 times x is 2x, and if we add those together, we're getting that -10x. Okay, so that worked out. I am going to go ahead and just erase my check real quick, but you guys were listening and following along, so you checked as well. All right, I meant to switch colors. Oh well. Now this 4 minus x, remember, we would love it if it was an x minus 4. So all we do is we factor out, it has a GCF of -1, so we factor it out, leaving us with x minus 4. Remember, you can do that little shortcut of switching the order of those two problems. So then we look for, or those two terms, look for anything that might cancel. X minus 4's cancel, leaving you with 3x plus 2 over negative 1. And then we can, it'll kind of look like what we just did. We can keep going. Oh, where's my marker? There we go. 3x divided by negative 1 plus 2 divided by negative 1. Our final answer is a negative 3x minus 2. All right, I hope you guys are so excited to learn how to do long division with our polynomials. But first, let's see if we can remember how to do long division with just regular numbers, regular integers. So here's a division problem. If we're going to do long division, we are going to set it up with, if it says 345 is being divided by 23. So remember, 345 for long division goes underneath our, probably should know these words, that division thing, and then the 23 goes outside. So what we're going to do is we are going to see how many times 23 will fit in. So first of all, 23 doesn't fit into 3, so let's expand it to 2 digits. Does 23 fit into 34? It sure does. It fits in 1 time, and so then we multiply 1 times 23 and we get 23. And then we subtract. 34 minus 23 is 11. We carry down the next digit, 5, and now we ask ourselves, how many times does 23 go into 115? 23 will fit into 115 5 times, and then we multiply 5 times 23, which actually is 115. It fits in perfectly, and then subtract, and we get 0. That 0 means that there is no remainder for our answer right now. Okay, so now let's take a look at this with polynomials. How does long division work? Okay, so when we do polynomial long division, let's set it up as a long division problem. This polynomial is being divided by x plus 2. So what that's going to look like is the x plus 2 is going to go out in front of that polynomial, x squared. Now, I did notice that this is not in standard form, so we do want to flip that around. We do want to put the plus 3x and then plus 2 on the end. All right, so when we do long division with polynomials, we start by focusing on just the first term, x squared, and the first term, x. We're going to take x squared, and I'm going to show the work off to the side, and if this helps you, you can do this too. X squared, and we're going to divide it by the x. So we're taking, what is x squared divided by x? Well, I can see x squared divided by x right here is just x. So I'm going to go ahead and put the x. And I am putting it over the x right here. I'm not sure how important that is, but that's what we're going to do. And now we multiply. We're going to take the x, and it gets multiplied with the x, so x times x is x squared. And then we have to multiply it by this whole polynomial, so we also have to do x times the 2. So x times 2 is plus 2x. I am going to put parentheses around this to remind myself to subtract both terms. X squared minus x squared will cancel. So now I'm looking at 3x minus 2x. 3x minus 2x is a 1x. And then you carry down your next term, plus 2. All right, now we no longer have an x squared. Now it's an x. So we're going to take this x and divide it by this x. Again, I can do that work off on the side. X divided by x equals 1. So that's what goes up top. Plus, because it's positive, 1. Now I'm going to take this 1 and multiply it to this polynomial. So 1 times x is x. 1 times 2 is a positive 2. And then we subtract. And basically, I can even see right here, it's an x plus 2 minus an x plus 2. That is going to give me a remainder of 0. So our answer is this guy up here. Our answer is x plus 1. Okay, let's try one more of those just to see if we can kind of get the hang of this polynomial long division. This is our last problem for our intro video. So we start by setting it up in long division. So what you're dividing by goes out front, x minus 2, and then 2x squared plus 3x minus 6. Okay, remember we start with just the first terms, 2x squared and x. So off on the side you can think about that. All right, well it's 2x squared divided by an x. So when I look at it that way, I can see, oh yeah, all right, well 2x squared divided by x is a 2, and then just an x to the first power. And then I'm going to multiply 2x times this polynomial. So 2x times x is 2x squared. If I'm doing this right, these should be exactly the same, so that when we subtract, they're gone. All right, then 2x times negative 2 is a negative 4x, and then we're going to subtract. So 2x minus 2x is gone. I guess you could cross it off if you want. Here's where we do need to be careful. We have a 3x minus a negative 4. So 3x minus a negative turns into, oh, did you guys catch my mistake? Eee. That should be an x right there. So remember we did 2x times negative 2 is negative 4x. Okay, now we're subtracting. 3x minus a negative 4x turns into 3x plus 4x, which is 7x. Then we carry down our minus 6. Okay, now we're done with the 2x squared, and now we have 7x minus 6. We're going to divide it by the x minus 2. So start with the first term, 7x divided by x. So over off to the side, 7x divided by x is 7. So we're just going to put plus 7. And then we have to multiply 7 times the x minus 2. So first we do 7 times x, which is 7x. And then we do 7 times negative 2, which is a negative 14. And then we subtract. 7x minus 7x does cancel. And then we have a negative 6 minus a negative 14. If I write that over here, minus a negative 14 turns into addition, which gives us a positive 8. And then you'll see, okay, well you don't have anything left to bring down, so that makes this 8 our remainder. So here's what you do with the remainder. Our remainder gets added on to our answer. This is our answer up here, 2x plus 7. So we add on our remainder, but we take our remainder divided by whatever we were dividing by over here, x minus 2. It looks funny, but this is our final answer right here.